Hi, friends. This is John. Welcome to the Regenerative Agriculture Podcast. Well, as I'm recording this, it's the beginning of July, and we're in early summer stage. Although for many of you listening to this, I know it's might even be fall or late summer. But it's at this time of the year and in the last couple of months where we get many of the phone calls that I think really set us apart as a company in the opportunity that we have to work with growers. And the nature of the phone calls is we're in the middle of the growing season and all of a sudden we have significant problems. What can we do about them? And the nature of these conversations, what I'm calling a significant problem is saying that, I'm growing wine grapes or a vegetable crop and I have severe powdery mildew pressure or I have severe Japanese beetle pressure. How do I manage this problem without using pesticides? Or I'm growing alfalfa and I have significant challenge with alfalfa weevil. How do I manage the alfalfa weevils? It's often in the regenerative agricultural context or conversation that is broadly evolving around the world, there is often this expectation that we need to invest in long-term soil health improvements, cultural management practices, and so forth, with the expectation that over a period of time, as soil health improves, as crop performance improves, then we can prevent a lot of these challenges from showing up in the first place. We can prevent the alfalfa weevils and we can prevent the Japanese beetles. And all of that is accurate, or at least it should be if we're implementing things well and we have a system solidly in place. But in the meantime, there's the growing season right now where we have Japanese beetles or alfalfa weevils or whatever disease or insect challenge shows up. And it would be really nice to have an immediate solution that isn't a pesticide. And it's in response to this need, as a result of me growing up on a fruit and vegetable farm and many of our early customers being high-value fruit and nut and vegetable crops. It's in response to this need that we needed to figure out how to have well-designed foliar applications of nutrition be very effective at changing the plant's nutritional profile and changing the plant's biochemistry profile, changing its disease and insect susceptibility very quickly. So for us as a company and for many of the growers that we start working with, this is actually a very exciting time of the year. Because it's at this time of the year when we get a lot of these phone calls where we're able to have conversations with growers. And can you imagine how much fun it is to be able to put on a foliar application and alfalfa weevils disappear, or the Japanese beetles disappear, or any other pest? It's a ton of fun. It's a ton of fun. But how do you do that? The tongue-in-cheek answer is the first step in the process is to call advancing eco-agriculture, but the tongue-in-cheek aside, how do you begin a regenerative agricultural journey and a pathway, or how do you accelerate it in the middle of a growing season when you have problems rather than going backwards? Because the alternative is, in some cases, the alternative is significant crop damage or to use a pesticide, neither of which are great options. But it's been our experience that we can manage. There's of course degrees of variation based on what's going on in your local agronomic context. Some situations are more difficult than others. But I would venture to say that greater than 80% of the disease and insect challenges that show up in the middle of a growing season are relatively easy to manage with nutrition and microbiome foliar applications. How do you begin in the middle of a growing season? Well, we begin by when we get these phone calls, of course, there's a conversation that needs to happen to understand the context of how did this come about? What are varieties? What has the historical agronomic management looked like? More specifically, in this particular growing season, what were the nitrogen applications like? What were potassium applications like? What fertilizer products have been applied? There needs to be a bit of an understanding of what the context is. But a great deal of the understanding for the context can be supplied by the identification of the pest itself. When we have aphids showing up, or spider mites, or alfalfa weevils, or Japanese beetles, the presence of a specific insect or disease can already begin to tell us a general shape and a general outline of what is going on within the plant from a biochemistry perspective. For example, we know that with a high degree of certainty that when we have a plant that has, or a crop that has spider mites showing up, there's almost a certainty that that plant will have elevated levels of ammonium inside the plant sap. And that elevated level of ammonium is a reflection of, it can be a reflection of high heat, a very dry, dusty, high heat environment, which means the plant is in photorespiration dominant mode and is actually generating the ammonium internally from catabolizing its internal proteins. So it may not necessarily be coming from applied fertilizer. But then that also means that the plant lacks the enzyme cofactors that are needed to convert that ammonia back into proteins. So these enzyme cofactors could be magnesium, it could be molybdenum, it could be boron, it could be sulfur, it could be some combination thereof. But simply having the presence of a specific pest, we can have kind of a general expectation, a general idea of what that plant's nutritional profile looks like. With aphids, for example, we would expect a plant that has aphid susceptibility to have a very distinctive carbohydrate profile and a distinctive nitrogen profile where we probably have elevated levels of nitrate, and in some contexts, we could also expect that we have chloride levels that are significantly higher than total nitrogen. So I use these as illustrations only to point out that given the depth of experience that we've accumulated over the last 15 years in managing disease and insect profiles with nutrition management, simply by identifying the crop and the pest that is present, in many cases that already gives us indicators of what the nutritional profile is going to look like. And so from this point, depending on the severity and the immediacy of the challenge, there are two possible approaches, two possible pathways to beginning right in the middle of the season. The first possible approach, and the one that is wisest and most conservative, is the one where we identify, obviously there's a problem, and in order to make an accurate recommendation that has a high likelihood of success, we want to not guess about what the plant's nutritional profile is, but we want to actually measure it. And this is where we use plant sap analysis. In my episode, a short episode a week ago, I had a conversation with Ethan Darling from our team here at Advancing Eco Agriculture, where we spoke briefly about the process that they use as a team to collect sap analysis, but you can find out more by looking at the Crop Health Labs website or by having a conversation with the team at Advancing Eco Agriculture on our approach to plant sap analysis. But plant sap analysis is a laboratory analysis process that measures the mineral profile in the plant sap that is much more sensitive to variation and therefore much more precise, and can also identify deficiencies 3 to 4 weeks earlier than with a tissue analysis, depending on the speed of plant growth. And this is a very important point. Sometimes we get negative feedback from growers who have used sap analysis, and they say, well, it takes so long to get the results back from the lab. It takes a week, or it can, and if they happen to hit a gap in a logistics window over a weekend or over a holiday or something like that, that it can take longer than a week. It can take 7 to 8 business days to get results back from the lab. And of course, this is less than ideal. However, even with that delay, you will still observe nutrient imbalances 14 to 20 days earlier than you will with a tissue analysis. Now, this is a very important point. Just because there is a time delay with the lab doesn't mean that tissue analysis is preferable. It just means we need to take that into consideration and be smarter about taking SAP analysis in a more timely manner. So this is the approach that I would prefer, is that we take SAP analysis results in the middle of the season, we get an accurate profile of exactly what's going on, and then we make a recommendation for a foliar application that is designed accordingly. Now, you might ask the question, well, John, if you already, when we tell you the disease or insect profile, and you already have some understanding of what the nutritional imbalances are likely to look at or to look like, considering that, then why not just skip the SAP analysis and just go immediately and directly to the field with a foliar application that is designed to solve that specific problem? This is strategy 2. You can do this. You can do this approach, and in some cases it's necessary to take this approach if we have a severe crisis and we need to have an immediate solution or the crop is going to be significantly damaged, and particularly if we have a high-value crop, then it's necessary to be able to make an immediate recommendation and apply it and hopefully solve the problem. And this is something that our agronomy team at AEA does quite frequently because it's very necessary. However, there is a challenge with this approach, which is that while because of our depth of experience, we have a high degree of success with this approach because of our understanding of what plant nutritional profiles look like, but it's still not perfect. With a SAP analysis, you can really dial in and you can have confidence in the recommendations that are being made that are a reflection of data and actually making recommendations based on data. But if we get a call that says we have flea beetle on canola or rapeseed, actually I'm going to use an aphid example. It's a really good example here. If we have aphid susceptibility within a crop and significant aphid pressure, then that immediately tells a story of the nitrogen profile. We have high levels of nitrates, we have a particular carbohydrate profile, and when we put on an application of photomag and boron, we can expect, so without knowing a great deal about the crop or about the specific context, we can make a recommendation for a foliar application of photomag and boron and perhaps C-stem, depending on other stuff that's going on agronomically. We might include 1 or 2 other products in the tank mix. And there's an 80% likelihood, perhaps even higher than that, that blind application without having data is going to be successful. But that means that it may not be successful 20% of the time. And that's an unacceptably high error rate, particularly when you're dealing with higher value crops and when you're dealing with the application costs of what it costs to apply product to a field today. And the reason for the error rate is that sometimes, in some particular contexts and fields, the aphid pressure isn't just the result of nitrogen profile, but it can also be a result of excess of chloride levels. When you have chloride levels higher than total nitrogen, and the high chloride levels actually are a significant pressure point for aphid susceptibility. So if you don't know that, and if you don't compensate for that in a foliar recommendation, then your foliar recommendation and application may have been 80% accurate, but you missed 1 or 2 things that were really important. And so this is a common scenario where we can get very close, but if we're missing information about what nutrient excesses might be present, then, and that information is not revealed with the SAP analysis data, then we have a lower certainty and a lower likelihood of success. So in some cases, from an expediency and timing perspective, it's necessary for us to make an application quickly and immediately. But in other cases, when we have the available time, when we have the bandwidth, it is wiser to use a SAP analysis to get the data, get the information, and be certain that we're making the best recommendation that we possibly can. And I'll leave you with one last thought, which is putting on a foliar application of nutrients in the growing season is the single most efficient and most effective way to apply nutrients. Some of the research that has been collated, and there's a bunch of this available online, but we find that nutrients are dramatically more effective when they're applied as a foliar than they are soil applied. So if you take nitrogen, for example, it's well documented that a pound of nitrogen applied as a foliar produces an equivalent crop response as 7 pounds of nitrogen applied to the soil. And all of a sudden it becomes very reasonable to say actually putting on foliar applications of nutrients later during the growing season is a lot less expensive, it's much more affordable, produces a much greater crop response, and the economics favor putting on foliar applications in season, as long as they are well designed. And this whole scenario, this scenario of being able to immediately address disease and insect pressure with nutrition management and getting more effective use out of plant nutrition. So there's this common desire when growers begin making a transition to regenerative agriculture practices. We understand that avoiding applications of excess of nitrogen and excess of nutrients at the beginning of the season, this is particularly true for nitrogen and potassium and phosphorus. Those three elements applied as a front-loaded application at planting are so problematic. It would be much better to front-load calcium and to front-load other elements, but that's not the mainstream practice. But when we front-load these nutrients, we can imbalance the system so severely and lead to all kinds of disease challenges, insect challenges, yield challenges. It's interesting that nitrogen and potassium in particular cause yield drag, while phosphorus does as well for that example when they're applied in excess. And all of a sudden, when we realize that we can actually reduce yield drag and we can increase crop performance by not front-loading and by applying some of these products later, putting on well-designed foliar applications becomes a win-win-win. And so it is in this context, in this approach, this way of thinking about plant nutrition disease management, that beginning a transition in the middle of the growing season actually makes a lot of sense. It's very valid. We don't have to wait to make soil health improvements or to begin cover crop applications and growing cover crops. We don't have to defer possible benefits and a transition into the future. It can happen immediately in this immediate crop season. And there aren't many things that bring about greater satisfaction than immediately solving a flea beetle or Japanese beetle or aphid problem or spider mite problem with a foliar application that is purely nutrition, and seeing that problem be completely resolved in 24 to 48 hours. That's a lot of fun when that happens, and very rewarding to think about that we developed a tool and a method for dealing with this problem that is not based on applying a pesticide. So those are my thoughts. It's a lot of fun and very valuable to have these tools that begin in the middle of the growing season and make immediate differences. So thanks for all the work that you're doing out there. If you have any questions on specific diseases, specific insects, specific challenges that you would like to begin resolving immediately, please send those to me. Send them to our team at AEA. And if there's an opportunity, we will address those on future podcast episodes and continue to have lots of fun conversations. Thank you all for the great work that you're doing. The team at AEA and I are dedicated to bringing this show to you because we believe that knowledge and information is the foundation of successful regenerative systems. At AEA, we believe that growing better quality food and making more money from your crops is possible. And since 2006, we've worked with leading professional growers to help them do just that. At AEA, we don't guess. we test, we analyze, and we provide recommendations based on scientific data, knowledge, and experience. We've developed products that are uniquely positioned to help growers make more money with regenerative agriculture. If you are a professional grower who believes in testing instead of guessing, someone who believes in a better, more regenerative way to grow, visit advancingecoag.com and contact us to see if AEA is right for you. Thank you for listening, and we look forward to working with you.